warahmatullahi wabarakatuh. So today we are going to introducing the Sonardi Ranger 2 USBL system, which is one of the most widely used underwater positioning system in the offshore industry. USBL stands for Ultra Short Baseline, a method of acoustic positioning that allows us to track the exact location of underwater targets such as ROV, divers, or seabed equipment. The Ranger 2 is developed by Sonardi, a company well known for its high-precision subsea technologies. This system is designed to provide real-time 3D positioning even in challenging environments like deep water or area with strong current. It's an essential tool for many offshore operations, from oil and gas exploration to underwater construction and survey work. In this presentation, we will explain how the Ranger 2 USBS system works, how it's used in the field, and why is it so important for safe and accurate underwater navigation.
Okay, in the operating for the Sonardin Ranger 2 USBL, and the procedure is the step one is the system setup. Firstly, we need to launch the Ranger 2 software on the control computer and then connect the USBL transceiver and sensors to the computer. Make sure all the devices are powered on and detected by the software. Step 2 is configure the navigation inputs. Set up the GNSS input, for example, the COM port, and then for the gyro heading, and then any other data. Enter the offsets for GNSS, gyro, and the USBL pole, aka the coordinates of X, Y, and Z. And then confirm the live sensor data is updating correctly in the Ranger 2. Step 3 is the USBL pole configuration. Define the pole mounting orientation, whether it's over the side or through hull, and then enter the pole length and the depth offset, and then perform the pole test to verify the alignment. And then the step 4 is the transponder setup. Enter the transponder address and channel in Ranger 2. Perform the acoustic test. Check for the replies and the signal strength. Mount transponders to underwater target. And then for the step 5 is tracking operation. Select target and click track in the software, and then monitor the position, range, bearing, and quality indicators in real time. Adjust tracking parameters if needed. And then the last step is the data logging and end operation. Start data logging for mission recording. After operation, click Stop Track. Safely retrieve transponders and use SBL transceivers, and then export the tracking data for post-processing.
Now, let's talk about what calibration means in the context of USBL system. Calibration, in the simple terms, is a process of adjusting and fine-tuning the USBL system so that it gives accurate underwater positioning data. A USBL system relies on several components working together, like the transceiver, GNSS, gyro, and the motion sensor. If any of these are misaligned, it can cause error in the position of the underwater target. So, calibration is done to correct for these small misalignments. This includes making the angles like pitch, row, and heading are properly aligned, and that the USBS system know exactly where it is on the vessel. We also make adjustment for sensor delay and mounting offset. By performing a calibration, we ensure that when the system reports a position, that position is as close as to the real locations as possible. This is especially important in offshore operations where accuracy is critical, such as pipeline inspection, ROV work, or subsea construction. So, why do we need to calibrate a USB system? The answer is simple: to ensure accuracy and reliability in underwater positioning. Without calibration, the system can give false or inaccurate position. Even a small error, just a few degrees off in the heading or pitch, can result in several meters of position error underwater. This could lead to an ROV missing its target, a diver being directed to the wrong location, or worse, a collision with subsea structure. Calibration correct those errors by aligning the system sensor with the accurate movement and orientation of the vessel. It gives us confidence that what we see on the screen reflects the real position of the beacon or subsea equipment. In short, USBL calibration is not optional. It's a critical step that ensures the safety, efficiency, and success of any offshore operation that depends on accurate subsea navigation. Now, let's go through the calibration step for the Sonardin Ranger 2 USBL system in more detail. Calibration ensures that the underwater position we record are aligned with the true movement of the vessel and beacon. This involves several key stages. The first step is system setup and configuration. Here we need to define the sensor offset. This means measuring the exact location of the USBL transceiver relative to the vessel GNSS antenna. This offset includes X, Y, and Z values, which must be entered accurately into the Ranger 2 software. At this stage, we also input the vessel draft, heading alignments, and movement and motion sensor offset to ensure everything is referenced correctly. Next, we deploy the calibration transponder beacon underwater. This beacon should be placed at a known depth and keep stable, often using a weight and line. It needs to be within the working range of USBL transceiver, typically between 10 to 100 meters. This beacon we add as our reference target during the calibration maneuver. Once the beacon is in place, the vessel performs a control movement around it. It is known as a calibration maneuver. The most common patterns are the box-in, L-shape, or arc. During this maneuver, we collect acoustic range and angle data from the transponder while simultaneously recording GPS and vessel motion data. It's important to maintain a steady speed and heading throughout to ensure high quality data. After the run, we use the Ranger 2 software to analyze the collected data. The system compares the measured position of the beacon with the expected geometry based on the vessel movement. If there are any misalignments, such as heading offset or pitch and row errors, they will show up clearly in the analysis. We then apply this correction directly in the software. This may involve adjusting the heading alignments, pitch, row, or transceiver offset values. Once the calibration parameters are safe, we perform a validation run, repeating the same maneuver to verify the correction. The goal is to bring the position error down to within acceptable limits, usually less than half a meter. So, in summary, USBL calibration is not just a technical formality. Is a critical process that ensures that the data we collect is accurate, reliable, and ready for safe underwater operation.
So I would like to share about USBL, which stands for Ultra Short Baseline. So USBL is an acoustic technology used to determine the position of underwater object. So it plays very important roles in various ocean-related fields such as offshore works, scientific research, and also oil and gas industry. So how does USBL works? USBL use sound wave to communicate between the transmitter on the ship and also a receiver underwater. So by calculating the times and direction of the sound, the system can accurately determine the object's position. So this is some application of USBL. First, tracking ROV and AUV. ROV are underwater robots controlled from the surface, and AUV is automatic ones. So USBL will help track their exact position during the task like underwater inspection or pipe repairs. And then next is laying underwater cables. So USBL is used to guide the correct placement of underwater cables such as fiber optics or power lines to ensuring they follow the right routes. So next, monitoring the movement of structure. So USBL will help monitor the position of floating structure. For example, is oil rigs in a real time. And then we have marine research, which is in ocean study. USBL is used to track marine animals, fixed with small transmitter, or to collect the data from sensor placed on the seafloor. And lastly is search and rescue operation. So USBL can help to find the sunken objects or victims underwater, such as during the plane crash investigation or shipwreck recovery mission. So this is the simple example, which is we can imagine an underwater robot is repairing a gas pipe. So without USBL, we will not know its exact locations. So if we have USBL, we can track it live from the ship, even if the water is deep and dark. So I will explain about the advantage and disadvantage. So the system has many advantages. First, it is very accurate. It can give us a very precise location of underwater objects even in a deep water. So this is important for the job that need high accuracy, for example like ROV operation or underwater construction. So second advantage is it can work over a long range, which is it can work up to about 11 kilometers. So this means we don't have to be too close to the object to track it. Another benefit is that it's easy to connect with other tools like sensors, ROV, and navigation system. So it's flexible and can be used for many different offshore tasks. And also, it can give real-time data or live tracking. So it is very useful when we need to monitor something continuously, like divers, ROV, or underwater equipment. However, the system also has some disadvantage. First is the cost. It is very expensive to buy and maintain, so it's maybe not suitable for small projects or low budget. Second is it's need trained user, because not everyone can use it easily without training, because it involves setting up the system properly and also understand how it works. Next is the time needed to setting it up. Sometimes, especially in rough sea condition, it takes time to deploy and calibrate the system. And lastly, the system performance can be affected by water condition. For example, the water noise, temperature layers, or obstacle between the ship and the objects can block or disturb the signal.
Now, I will present several agencies in Asia that are currently using the Sonardin Ranger 2 USBL system for offshore survey. The system is widely used for underwater positioning, especially in the oil and gas and renewable energy sectors. First, the first agency is China Offshore Fugro Geosolution, or COFG. It is a joint venture between Fugro and China Oilfield Service Limited. They have been using the Ranger 2 system and combined it with Sonardin Gyro USBL to track ROV during pipeline surveys at the Liwan 3-1 gas field in the South China Sea. This highlights the system reliability in deepwater operation and harsh conditions. The next one is 10 Nam Positioning JSC from Vietnam. In Vietnam, 10 Nam Positioning JSC has invested in their first Ranger 2 SBL system through Sonardin Singapore. The system is used mainly for ROV tracking, subsea installation, and pipeline projects in the oil and gas industry. This agency has represented how local companies are adopting advanced underwater positioning technologies. And the last one is PDE Offshore Corporation from Taiwan. PDE Offshore is a leading geotechnical service provider in Taiwan. They have upgraded their offshore vessel, including the geoenergy and geopower with Ranger 2 system. These vessels are involved in seabed and soil investigation for offshore wind farm development in the Taiwan Strait. This has shown how Ranger 2 has supported the growing renewable energy sector. To conclude, the Sonardin Ranger 2 USBL system has proven to be a reliable and accurate solution for underwater positioning in offshore operation. From oil and gas pipeline surveys in China to renewable energy site investigation in Taiwan and Vietnam, the system is trusted by leading agencies across the Asia. Although there is limited public information of its direct use in Malaysia, the technology is accessible through the regional partnership and service providers. This has shown how advanced the acoustic positioning system like Ranger 2 has played a vital role in supporting marine survey, construction, and monitoring activities. As offshore industry continue to expand, especially in the Southeast Asia, the demand for such precise and efficient system will only grow. So that's all from us. Thank you.